Here is a sentence that should not make sense. A rocket company just agreed to pay $60 billion for an app that writes code. Not a typo. $60 billion for a text editor. And the strangest part is that by the end of this video, it is going to sound almost reasonable. So let me say it precisely because the precision matters. On June 16, 2026, SpaceX agreed to acquire the company behind a tool called Cursor in an all-stock deal valued at $60 billion. Agreed to acquire. Not bought, not owns. It is signed, but it is not yet closed. That leaves two questions hanging in the air, and they are the two questions this whole video answers. First, what actually is this thing, this Cursor, that a rocket company wants so badly? And second, why on earth would it be worth that much? Let us take them in order, because the second answer only lands once you really understand the first. But first, the obvious objection. Why is a rocket company buying a coding tool at all? The answer is that SpaceX is not just a rocket company anymore. Follow the chain. In early February of 2026, the artificial intelligence lab xAI, the maker of the chatbot Grok, merged into SpaceX. xAI no longer exists on its own. It was folded into a division. So the SpaceX that signed this deal already owns a frontier AI lab. Then, just days before the deal, on June 12th, SpaceX went public on the Nasdaq, under the ticker SPCX. Reportedly the largest initial public offering ever recorded, raising around $85.7 billion after the so-called greenshoe, the overallotment option, was exercised on June 15th. So here is what that means. SpaceX now has an AI lab, and it has freshly minted, publicly traded stock to spend. An AI company with a full wallet, looking for the one thing it does not have yet. Hold that thought, because to see why this particular product is the prize, you have to open it up and see what is actually inside. So let us start with the problem Cursor exists to solve. Imagine you are a developer and you have a question about your own software. You open a normal chatbot and you paste in the one file you are stuck on. The chatbot reads it and gives you an answer. But think about what it cannot see. It cannot see the other 200 files in your project. It cannot run your code to check if its answer even works. And it cannot apply its own suggestion. It just hands you text and you copy it back by hand. That is not a knock on the model. The model is genuinely capable. It is a workflow problem. A standalone chatbot is, by design, blind to your repository. It is a brilliant stranger you text snippets to, who texts answers back over a wall. Cursor's whole idea is to tear down that wall. Instead of texting a stranger, you put the assistant inside the editor, with its hands on the keys, able to see everything and act on it. That single shift, from outside the loop to inside the loop, is what the next several minutes are really about. So what is Cursor, concretely? It is a code editor, a desktop application that developers write software in, and it looks and feels almost exactly like a popular editor called Visual Studio Code, or VS Code, made by Microsoft. That is not a coincidence. Cursor is literally a fork of VS Code. A fork means they took the open-source version of that editor and built their own version on top of it. And this is the architectural choice that makes everything else possible. The original way to add AI to an editor was a plugin. A plugin is like one robot arm reaching in through a single slot in a sealed glass box. It can only touch what it can reach through that slot. But because Cursor owns the entire editor, the AI is not a plugin reaching in. It is wired into every layer of the building. It can see your edits, your cursor, every open file, your whole repository, the terminal, and the review screen where you accept or reject changes. AI in the core, not bolted on the side. That is why Cursor can do things a simple plugin never could, like understanding your whole project at once and changing many files in a single clean step. Now we hit the first real engineering puzzle. A large AI model cannot simply read your entire codebase at once. There is a hard limit, called the context window, on how much text it can hold in mind at one time, and a serious project is far too big to fit. So Cursor does something clever. Before you even ask a question, it builds a searchable memory of your code. It happens in 3 moves. First, it takes each file and splits it into chunks, not at random line breaks, but at meaningful boundaries, a whole function here, a whole class there, using a structural parser called treesitter. Second, it turns each chunk into an embedding. An embedding is a list of numbers, a vector that captures the meaning of that code, so that pieces of code that do similar things end up near each other in a kind of high-dimensional space. Your login code clusters in one region, your payment code in another, even if they share no words in common. Third, all those vectors get stored in a specialized database built for fast meaning-based search, called a vector database. Cursor uses one called turbopuffer. So the key idea is this. The model is never trained on your private code. Instead, the relevant slice gets fed to it on demand. Cursor builds a map of your repository so it can find that slice fast. Here is a follow-up problem. Your code changes constantly. Every time you save a file, does Cursor have to rebuild that entire memory from scratch? That would be hopelessly wasteful. So it uses a beautiful little structure called a Merkle tree. Picture a tree of fingerprints. Every file gets a hash, a short fingerprint of its contents, and that is a leaf at the bottom of the tree. Every folder gets a fingerprint derived from the files inside it, on up the tree, until a single fingerprint at the very top represents the whole project. Now when you change just one file, only that file's fingerprint changes, and that change ripples up only the one path from that leaf to the top. Every other branch stays untouched. So by comparing 2 of these trees, Cursor can tell instantly and exactly which files actually changed, and reprocess only those. Everything else is left alone. This resync runs roughly every 5 minutes, quietly keeping the memory fresh without ever redoing the whole job. A tiny, elegant trick for staying current on the cheap. Now we can put the memory to work, and this is the central trick of the whole system. When you ask Cursor a question, it does not dump your entire codebase into the model. It cannot remember the context window. Instead, it does 3 things. First, it takes your question and turns it into an embedding, a point in that same meaning space you built earlier. Second, it runs what is called a nearest neighbor search, also known as a similarity search. It simply looks for the chunks of your code that sit closest to your question in that space, the ones most related by meaning, and it mixes in a plain text keyword search, using a tool like grep to catch exact symbol names too, a hybrid of find by meaning and find by exact match. Third, it takes just those handful of relevant chunks and adds them to the prompt before sending it to the model. Retrieve the relevant context, then generate the answer. That pattern has a name you will hear everywhere. It is called RAG, Retrieval Augmented Generation. And it is the reason a model with a finite window can reason about a code base far larger than that window. It is never holding your whole project. It is being handed exactly the right pages, right when it needs them. Let us move from the big picture to the moment-to-moment feel of using it, starting with the feature people fall in love with first. It is called Tab. Now, ordinary autocomplete, the kind you have seen for years, predicts the next word or the next token as you type. Cursor's Tab does something more ambitious. It predicts your next edit. Watch the difference. As you work, Tab is reading your recent changes, the surrounding code, and any errors your linter is flagging. And instead of finishing a single line, it proposes a whole multi-line change, adding the import you forgot, fixing a function's signature, completing a refactor you just started. And then this is the part that feels like magic. It jumps your cursor to the very next place that needs a matching edit. You press Tab, it makes the change and jumps. Tab again, change and jump. It can even reach across into a different file when one change forces another file to update. Tab, tab, tab. It runs on Cursor's own fast, in-house model, engineered for sub-second response. And it is the single most used feature in the whole product. reportedly handling more than 1 million requests per second at peak. But here is the question that actually matters for the rest of this story. Why does Tab keep getting better? And the answer is a real training mechanism, not a slogan. Every single time a developer presses Tab to accept a suggestion or dismisses it and keeps typing, that is a signal. Accept means good. Reject means bad. It is a labeled human preference, generated millions of times a day, for free by real developers doing real work. Cursor feeds those accept and reject signals back into the model using a technique called online reinforcement learning, and it ships new versions of the Tab model multiple times a day, each one a little sharper than the last. Remember this loop, because it is going to come back at the very end as the heart of the $60 billion argument, and the payoff is documented. An upgrade called Fusion, shipped in January of 2025, predicted around 25% more difficult edits than the previous model, suggested stretches of change roughly 10 times longer, cut the server delay from 475 milliseconds down to 260, and more than doubled how much code Tab could consider at once, from 5,500 tokens to 13,000. A spinning data flywheel, made of nothing but people pressing one key. Now, a subtle split that is easy to miss but worth understanding, because it is a small masterpiece of engineering. When Cursor changes your code, it actually uses two different models, with two different jobs. The big frontier model, something like Claude or GPT or Gemini, is brilliant at reasoning about what should change. It writes the plan and the new code. But it turns out that making a big, smart model carefully retype an entire edited file is slow and surprisingly error-prone. It gets lazy, it miscounts line numbers, it drifts. So Cursor hands that mechanical part to a second, specialized model called Apply or Fast Apply. And Apply has a clever trick that Cursor calls speculative edits. Think about it this way. The new version of your file is mostly identical to the old version. So Cursor feeds the old file to Apply as a high-confidence draft, and the model only does real work in the few spots where the code actually changes. The unchanged lines are accepted in bulk almost for free. The result is a precise rewrite at around 1,000 tokens per second, reportedly many times faster than doing it the naive way. And that output becomes the diff you actually review on screen. One model thinks about what to do. A faster, leaner specialist does it. Plan, then apply. So far, we have a tool that completes your edits and applies changes. But the real leap is when you stop describing individual edits and just describe a goal. That is the agent loop. You say what you want once and the agent runs a cycle. It reads the relevant files using that retrieval system from before. It makes a plan. It edits across however many files the task touches. It runs something, a terminal command, your test suite. It checks the result. And if a test fails, it reads the failure, figures out what went wrong, fixes it, and runs the loop again. Read, plan, edit, run, check, fix, repeat, until the job is done or it reaches a point where it needs your approval. Composer is Cursor's own fast model tuned specifically for this multi-file loop. There is also a cloud or background agent that runs the same loop off your machine entirely, taking a task all the way to a finished, ready-to-merge code change. And through a standard called MCP, the Model Context Protocol, the agent can reach beyond your code to query a database, read your documentation, or file a ticket through one common interface. This is a real working loop, and it is genuinely getting better. Its limits are engineering trade-offs, not a ceiling. And here is the recent shift that changed how the whole tool feels. Until lately, you ran one agent at a time and waited. Now, the loop runs many wide. In a release called Cursor 2.0 in late October of 2025, Cursor added something called the Agents window. It lets you run up to around 8 agents in parallel, all at once. And to keep them from overwriting each other's work, each agent runs on its own isolated copy of the code, on its own separate Git branch, what developers call a worktree. You supervise all of them from one central console. Picture giving the same task to 8 different workers, letting them all attempt it independently, and then simply merging in whichever solution came out best. Then, in Cursor 3, in April of 2026, this became the default way the whole editor works. The interface was reorganized around orchestrating agents, rather than typing in a single file. To be precise, parallel multi-agent shipped first in 2.0. Cursor 3 made it the front door. The editor stopped being a place you type and became a place you direct. Now a question you might be asking. With all these different models flying around, which one is actually doing the work? And the answer reveals what Cursor really is underneath. Cursor is a router. For every request, it sends the work to the best backend for the job. The latency-critical work, the instant tab completions, and a lot of the agentic editing runs on Cursor's own fast, in-house models. But the heavy reasoning, the deep thinking about a tricky refactor, gets rooted out to the big frontier models: Anthropic's Claude, OpenAI's GPT, Google's Gemini, xAI's Grok. You can pick a specific model or leave it on auto and let Cursor choose per request, balancing speed against capability. And here is an honest beat that matters. Most of the heavy reasoning runs on those third-party frontier models, not on Cursor's own. So Cursor, at its core, is not one magic model. It is the entire system built around the models. The index, the retrieval, the agent loop, the routing. Hold on to that, because it is the seed of the big question at the end. If the smarts mostly come from someone else's models, then what exactly is worth $60 billion? And yet Cursor does train its own flagship model called Composer, and as of mid-2026, how it is built is public, from Cursor's own engineering write-ups and a technical report. This matters, so let us go one level deeper. First, Composer is a mixture of experts model. Often shortened to MOE, the idea is that the model contains many specialized subnetworks, called experts, but only a small subset of them activate for any given token. So the model can be enormous in total capacity while staying fast to run, because most of it sits quiet at any moment. That is the architectural choice behind its speed. Second, it is built in 2 stages. Cursor starts from an open model checkpoint, reported to be one called Kimi K2.5, and runs a phase of continued pre-training on a code-heavy diet to deepen its coding knowledge. Then it does large-scale agentic reinforcement learning, letting the model practice in hundreds of thousands of real sandbox development environments, using real search, edit, and test tools to actually solve tasks. The result is reportedly around 4 times faster than comparable frontier models, and something striking happened during that training. The model learned on its own to run codebase searches, to fix its own errors, and to write and run its own tests, behaviors nobody explicitly programmed. So Composer is not a black box, and it is not just a wrapper. It is a real, trained model, and that fact is load-bearing for everything that comes next. All right, we have seen how Cursor works under the hood. Now let us zoom out and lay the whole tool on the table so the how-to that follows has a map. At the center sits the agent, the thing that runs that read, plan, edit, check loop. Around it are the surfaces you actually touch. Tab, the next edit, autocomplete. Inline edit for quick focus changes right where your cursor is. Chat, the conversational panel where you talk to the agent. And the context system, which decides what the AI gets to see, made up of the codebase index, at mentions for pulling in specific files, rules for setting persistent conventions, memories for remembering facts across sessions, and MCP for connecting outside tools. Then, layered on top, you have BugBot, an automated reviewer for your pull requests, cloud agents that work off your machine, and a command line version for your terminal. Here is the unifying idea that ties it all together. It is the same agent in 3 places: in your editor, in your terminal, and in the cloud. Learn it once and it follows you everywhere you work. Let us get you running because it takes about 60 seconds. Step 1. Download Cursor for your operating system. There is a native installer for Mac, for Windows, and for Linux, plus a command line installer if you prefer. Step 2. Launch it and sign in. Step 3, and this is the nice part on first launch, accept the one-click import from VS Code. It brings over your extensions, your settings, your themes, your keyboard shortcuts, everything. Because Cursor is a fork of that editor, it will feel instantly familiar like you never left. Step 4. Open a folder containing your code. Indexing, that memory building we talked about, starts automatically, and semantic search becomes usable at around 80% indexed. Step 5. Press Command and I to open the agent and just ask it in plain English to explain the codebase. Tell it to search the repo, read the relevant files, and summarize how it all fits together. You do not need any special command for whole repo search. You just ask, and the agent runs its own search over the index for you. And step 6, the habit that will save you. Start with a small, low-risk task. Review the change it proposes, and verify it with your own tests and tools before trusting it. Now the 2 fastest surfaces, the ones you will use every minute. First, tab in practice. As you type, a gray suggestion called ghost text appears ahead of your cursor. Press tab to accept the whole thing, or press command and the right arrow to accept just the next word if you only want part of it. Press escape or just keep typing to reject it. And after you accept, press tab again for the jump, where cursor predicts and leaps you to your next edit location. You can manage all of it from the small status indicator in the bottom right corner, snoozing it or turning it off per file type. Second surface, inline edit for a surgical change. Highlight the code you want to change. Press Command and K, type your instruction in plain English, something like, convert this to an asynchronous function. Press Return to apply and review the color-coded diff that appears right there inline. If it is not quite right, refine it with another instruction or accept it. 2 surfaces, 2 muscle memories. Tab for what comes next as you type. Command K for a precise change to what you have already written. For anything bigger than a single edit, you open the main workspace with Command and I. This is the chat and agent panel. You type your task in natural language, and you watch a live timeline as the agent searches your code, reads files, and runs commands, showing you each step. Now a crucial control. The agent has modes and you rotate between them by pressing Shift and Tab. The 3 you will use most are these. Agent mode, for straightforward changes you have done before, which is the default. Plan mode for complex, multi-file, or ambiguous work, where you want it to think and propose an approach before touching anything. And ask mode for questions only, where it answers without editing a single file. Here is the core discipline, the most important habit in the whole tool. As the agent edits, review the diffs and accept or reject at the right level of detail. You can accept the entire run or reject all of it. But you can also go file by file, taking the good files and rejecting the rest. Or even hunk by hunk, accepting one changed block inside a file and rejecting another. You are never forced into all or nothing. And if the agent goes off the rails, hit stop or press escape immediately. There are also automatic checkpoints, snapshots taken before big changes, so you can rewind to a known good state at any time. When a long conversation starts to drift, just start a fresh chat. Now the part that separates a frustrated user from a fluent one, controlling what the AI sees. The single most important thing to know is this. Whole repo search is automatic. There is no special command to type. If you want Cursor to understand your whole project, you just ask your question in plain English, and the agent runs its own semantic search over the index and pulls in the right files for you. So if you are not even sure which file matters, do not guess. Just ask and let the agent find it. When you do know exactly what you want to pin, you type the @ symbol to add precise context. @files or @folders for a specific file or directory. @docs to pull in library documentation. @web for a live web search. Beyond that, you steer the agent's behavior over time with rules, persistent instructions you write in a .cursor/rules folder or in a plain markdown file called agents. MD, things like your coding conventions and your tech stack checked right into your project. There are memories, facts the agent captures from your chats and recalls later. And there is MCP for connecting external tools and data sources. One quick troubleshooting note. If the agent keeps missing obviously relevant code, the problem is usually the index, not the model. Open the indexing settings, confirm it is fully indexed, and check that a file called .cursorignore is not accidentally hiding the code you need. The agent does not just live in your editor. It follows your work all the way out the door, into review, into the cloud, and into your terminal. First, review. There is a feature called BugBot. Connect your code hosting account, GitHub or GitLab, and BugBot automatically reviews your pull requests, the bundles of changes you propose before merging. It reads the diff, looks for bugs, security issues, and quality problems, and leaves inline comments right on the lines that need attention, with suggested fixes. Second, the cloud. Cloud agents run that full agent loop in an isolated cloud machine with no connection to your laptop required. You hand one a task or even just point it at an issue, and it works on its own branch, builds, tests, and opens a ready-to-merge change for you, complete with screenshots and logs. One caution. Cloud agents run on the more expensive setting, so set a spending limit before your first run. And third, the terminal. There is a command line version of the very same agent. You can run it interactively or script it into your automated pipelines for hands-off workflows. Same agent, same rules, same connected tools, just driven from the command line. Review, cloud, terminal. The assistant goes wherever the code goes. A few dials worth knowing before you commit. First, models. Use the model drop-down in the chat input or press Command and / to cycle through them. Leave it on auto and Cursor balances intelligence, cost, and reliability for you. Or pick a specific model including Cursor's own composer when you have a known need. There is also a max mode, which maximizes the context available for genuinely hard tasks, though it is billed at higher rates. Second, privacy. Privacy mode is a setting that guarantees your code is never stored or used for training by Cursor or by the model providers. Cursor reports having zero data retention agreements in place with the major providers. It is on by default for teams and enterprise plans. One catch worth naming. If you bring your own API key, that own key path works for chat only. Tab apply, and the agent always run on Cursor's own models, so a personal key never covers those. And third, pricing as of June 2026, so re-verify it. There is a free tier to try it. Pro at $20 a month, Pro Plus at $60 a month, Ultra at $200, and Teams and Enterprise plans above that. The most important cost habit, set a monthly spending limit in the billing settings, so over-limit requests stop instead of silently charging you. Now a habit that matters as the agent gets more autonomous, and the right way to think about it is safety, not fear. Here is the risk. An agent that runs terminal commands, reads your repository files, reads GitHub issues, and calls outside tools, is constantly reading untrusted text. And that text can carry a hidden attack called indirect prompt injection. Imagine a malicious instruction buried inside a code comment, or an issue, or a web page, or the output of some connected tool, quietly trying to hijack the agent into, say, leaking a secret or running a harmful command. The real danger shows up with blanket autorun, letting the agent execute commands with no approval. Cursor has real defenses against this. Per tool approval, so you confirm actions. A command allow list. A sandbox that restricts network and file system access. And an automatic review classifier that screens commands to cut down on prompts. But here is the discipline, and this is the actual teaching point. Do not blanket auto-run everything. Keep yourself as the approval gate. Scope your connected tools to only what they need. Use restricted, least privilege keys. And review what the agent actually runs, the same way you review its code. One reported episode drives this home. A disclosed vulnerability showed that even a sandbox can be bypassed. So treat the automatic review as a convenience, not as a hard security boundary, and keep the human in the loop. A capable tool plus a few good habits equals safe. Not, you cannot trust it. So let us answer the question we opened with. Why is this better than just pasting code into a chatbot? And the honest answer is a difference in mechanism, not a claim that AI cannot code because it clearly can. Two things. First, it is codebase aware. A chatbot is blind to your repository and guesses from generic training. Cursor retrieves the relevant slice of your actual code through that index and retrieval system, so an answer about where your authentication happens is grounded in your real files. Second, it lives in the loop. Cursor can edit the files, run the terminal, run the tests, read the failure, and try again. A chat window can only hand you text you then apply by hand. A smart stranger you text code to versus a teammate sitting at your keyboard. And that fit shows up in real jobs. Autocomplete as you type, surgical inline edits, big multi-file refactors, explaining an unfamiliar code base, debugging, writing tests, building a whole feature from a single prompt. There is even a telling trend in how people use it. Reportedly, back in March of 2025, far more people used Tab than used agents. By April of 2026, that flipped to roughly twice as many running autonomous agents. That inversion is exactly why Cursor rebuilt its entire interface around agents. How widely is this actually used? The honest answer, the numbers depend on what you measure, and they come largely from the company, so hold them loosely. With that caveat, Cursor reports over 1 million daily active users as of late 2025, more than 50,000 companies building with it, and by its own count, over 100 million lines of enterprise code written with it per day in 2026. Named customers with their own reported figures include companies like NVIDIA, Salesforce, Coinbase, and Stripe. But now the limit, and this is non-negotiable, so let me state it plainly. Cursor can produce code that looks completely plausible and is quietly wrong, especially on unusual APIs or tricky logic. It might invent a function that does not exist, or claim a fix works when it ran the wrong test. This is not a flaw unique to Cursor. It is how every large language model behaves. The countermeasure is discipline. Read the diff, run the tests yourself, and never merge code you do not understand. Even the makers got bitten by this. Back in April of 2025, Cursor's own AI support bot confidently hallucinated a company policy that did not exist and labeled it expected behavior when there was no such policy. A co-founder publicly acknowledged it was an incorrect response from a frontline AI support bot. The lesson is simple. Treat AI-generated code as a draft until a human reviews it and the tests pass. The product is built around that review step for exactly this reason. Now we can finally answer the question we started with. Why would anyone pay $60 billion for this? And the argument rests on three things you have already seen working. The first is the interface. Frontier models keep getting commoditized, several labs, all roughly competitive, racing each other. The durable value moves to whoever owns the daily interface, the actual place where developers accept AI's work and write the world's software. Cursor is that place for a huge slice of professional engineers. The second is the data flywheel, and this is not hand-waving because you already watched it run. Remember Tab, trained on accept and reject signals. Remember Composer, trained with agentic reinforcement learning. Millions of developers accepting and rejecting AI edits all day generate a uniquely rich stream of preference data, real tasks, real acceptance, real fixes, exactly the signal that trains better models. Grok, the chatbot SpaceX already owns, does not have that. Pair that data with SpaceX's enormous computing power, and you get interface, plus data, plus compute, all under one roof. And the third is the bet that coding is the killer application of advanced AI. If software creation is the first place AI delivers broad economic value, then the company that owns the coding loop owns the most valuable application of all. On those terms, 60 billion can look almost cheap. And remember that recently public stock is the currency. SpaceX is paying with its own shares. Buy the interface instead of trying to build it. But let us be fair and Steelman the skeptic, because there is a real case on the other side. First, the interface is a thin layer and a forkable one. Cursor is, after all, literally a fork of someone else's editor. A frontier lab or a platform owner that controls the underlying tools could attack that same daily habit. And the most loved tool in some developer surveys is not Cursor at all. It is a rival from a frontier lab. Second, the flywheel is easy to assert and hard to prove. And remember the honest beat from earlier. Most of Cursor's quality today comes from third-party models it roots to, not from its own. Third, the money. Cursor pays for a lot of that inference, often to its own rivals, and it has reportedly run on thin or even negative margins, with some individual accounts losing money. It is priced on a dominant future, not its current base. And fourth, the whole premise that AI writes the world's software profitably soon is a bet, not a settled fact. Some careful studies have found that experienced developers were sometimes actually slower with AI assistance on mature code bases. So the right framing is this. Cursor is a leader, not the guaranteed winner. Who is winning depends entirely on the ruler you use. By paid seats, one rival leads. By model spend, another. By standalone editor revenue, Cursor. By satisfaction, yet another. It is a multi-lane market and the race is not over. So let us end exactly where we began, but now with the precision the headline never gives you. SpaceX agreed to acquire the maker of Cursor for $60 billion, but sit with the details because they are the truth of it. It is all stock. No cash changes hands. The recently public SpaceX stock is the payment, and an initial public offering is what made that possible. The $60 billion price is fixed, but the number of shares is not. The exact share count gets set only at closing, based on the average price of SpaceX stock over the 7 trading days right before the deal closes. So the price is locked, but the shares floats. And most important of all, this deal is signed, but it is not closed. It still has to pass a regulatory gate it has not yet cleared, with a target of sometime in the third quarter of 2026. It can still slip or be blocked. In fact, the agreement reportedly includes break fees, around $10 billion in general, plus a separate $4 billion if it is blocked on antitrust grounds, fees that exist precisely to price the risk that it does not go through. So here is the whole thing in one line. This is not a rocket company buying a text editor. It is an AI conglomerate paying with its own stock to try to own the place where AI writes the world's software. The headline will age. The deal might even fall through. But the reason it makes sense, the interface, the data, the loop, that lesson outlives the news. Thanks for watching.